Good morning, everyone, and thank you all for joining us today. My name is Rashmata, and I am the event planner for Microsoft Reactor India. This session will run over the next 60 minutes, including Q&A. But before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section will be open throughout, and we do encourage you all to participate. So please feel free to drop all your questions in the chat section. I would now like to welcome Divakar, our speaker for today's session. Divakar is a Microsoft MVP in AI and a Microsoft certified trainer working as a technical architect at Fliersoft. But for now, I will hand over to Divakar to begin the session. Let me bring him into the stream.
Hey, Rasmita.
Hey, Divakar, how are you doing this morning?
Yeah, I'm doing good. How are you?
I'm doing good. Thank you so much for hosting this session. Let me bring up your screen. And yeah, over to you, Divakar.
So, let me start my screen. Okay. Hello, everyone. Uh, Welcome to today's session. Thank you for joining us live today. Today, I will be covering some of the introductory concepts of durable multi-agent application, which is an open source project that I have been working for the past few months. I started it from the scratch, and over the period of time, it rapidly evolved. But first, let's talk about why this matters to you. By the end of the session, you will be having a high level understanding of what a durable multi agentic workflow is, how it is different than other multi agent architectures that we have currently, and what are the additional benefits does it bring to the table, and how to implement one. So, this will set the foundation for you to understand some of the deeper concepts that we will cover in the further sessions that we plan in the future. I will also share some of the key design considerations that I had in my mind while building this application. The goal is to give you a perspective that you can use as an approach whenever you are building an agentic application. You can also reach out to me personally on LinkedIn or drop a comment in the YouTube so that I can address your queries once the session is over. So before getting into the detail, just a bit of a context about myself. I am Divakar. I work as a technical architect at Fliersoft. Apart from my work, I'm really passionate about sharing the knowledge, and I write some blogs around some interesting topics. You can find them in this link. And below is the GitHub and LinkedIn handle for mine. So you can always reach out to me if there are any queries related to today's session. So with that, let's take a look at what I have built and what you will be getting as part of this suite. So this project is based on a travel agency use case, where a typical use case involves a user requesting for some travel recommendations, and there are multiple agents behind the scenes working autonomously to address their needs. So the flow will be like we are having currently three agents working together to book a travel for that particular user. Flight agents, weather agents, and then the booking agents. So we will see in detail like how these interactions are made, how the things are connected together. So this is what you will be getting as an suite of different implementations. So first of all, you will get to know like how to implement multi-agentic workflows with the help of Azure Durable Functions that allows you to build a durable, resilient application, even if it is going to be an agent-to-agent interaction. And the next part is you will be getting multiple support for different kind of agents. You can start with a single agent. We do have a support for that within this application, and you can compare the performance between a single agent and the multi-agent. And within the multi-agent, we have different kind of implementations. You can have your own custom workflows with the help of durable functions. Also, you can make use of AutoGen, which is a multi-agentic framework tool. You can also make use of it. And finally, there is an real-time agent support as well, where you can have voice-to-voice interaction with the user. On top of that, we also have semantic layer integration. So instead of storing the normal transactional data, now you also store the semanticness of those data and create vector embeddings on top of those data to effectively retrieve those informations while you are implementing RAG solutions. And finally, we also have an integrations with Microsoft Fabric, which is an unified data platform, a SaaS solution that allows you to visualize the data and create some meaningful insights from your data. And this is going to be our agenda for the next 40 to 50 minutes. So we will start with an introduction on what is a GPT model and what is an agent and how we evolved into multi-agent and why specifically we need a durable multi-agent. Then we will move on to Azure Durable Functions, why I chose a serverless architecture to implement this workflow, and why specifically we went with Azure Durable Functions, and different patterns that are within the durable functions that helps us to build this agentic workflow. And further, we will also look into the memory store, because that is one of the key aspects of any agent you want to develop. You need to have a memory store. We will understand like why we chose Azure Cosmos DB as one of the memory store, and also we will understand its native vector search capability along with the semantic layer. And we will see an introductory session on the semantic kernel, how it helps for the enterprise app developers to develop this agentic application, and how it is different than other frameworks that we currently have, like the LangChain or the prompt flow. And finally, we will see why we need a monitoring or observability within our agentic applications more than ever now. And we will also see a bit about the Microsoft Fabric integration. So with that, let's move on to the introduction. So at least once some of us would have interacted directly or indirectly with a GPT model. So all of us would have used ChatGPT website, now DeepSeek has came. So in a way, we are interacting with an LLM, but the most naive way from a developer perspective, if you want to look at, it is similar to having a REST API interaction. So you will be sending some request payload that will be in the form of prompt. So that will be sent to the GPT model, and GPT model will send you back with a completion request. This will be the response body that you will be receiving from the LLM. So the prompt has two different variants. One is the system prompt and the other one is the user prompt. User prompt is something that we ask as a query to the LLMs, and system prompt is something that where you will be defining the persona of that particular LLM, and also where you will be providing some context to it. So this is some of the naive way of interacting with an LLM. Then we started to evolve. We did augmented generation. That means like we injected some context to the system prompt, and based on that, we retrieved some answers from the LLM. Because all these LLMs are trained on the past data. So if you are gonna ask for some new information or recent query, then it won't be able to answer those queries. So for that, what we will be doing is like we need to augment those context to the LLM, then it will be able to ground those information and give back your response. So this is a concept called augmented generation. And then we evolved from that. We started to build a retrieval augmented generation. So where you made use of some database, it could be a traditional relational database or non-relational database. And also it could be a vector database as well, where you store the information in your database and make use of it while retrieving the information and providing it as a context to the LLM. And further, recently we were getting into this agentic workflow phase. where along with this context, now we also need to send in some tools. These are essentially some method calls that you define within your application in order to interact with the external world. So that is what tools does. And along with that, you also now need to send in the chat histories as well. Say, suppose you were past few conversations that you need to bind along with every conversation, you can do that as well. But the main part that will differentiate the normal LLM agent from the actual agent is if your LLM does these three things, if it thinks and decompose the task based upon the query that you the feed into the context, and if it performs an action with the help of tools that you provide with them and make use of a memory to provide some end result, which is known as an observation. This could be an end result or this could be an intermediate result. Then your LLM can be called as an agent. So if it thinks, performs action and produce an intermediate result, this could be called as an agent. And when this happens in a loop, because until unless you reach the end goal, you need to have this in a loop, and your agent will does that. So until you derive to an end result, your loop will be carrying on, and at the end you will be getting a completion model from the LLM. So this is called this is known as an agentic workflow. So then we started to evolve. We made use of multiple agents, as the name suggests. So we went with different agents. So earlier we were using only single agent for even for a complex use case. Then we started to give responsibility for different agents to hold different business contexts, and they were handling on their own. So this is what multi-agent framework does. There are different tools for you to build this kind of a framework, like AutoGen does that, QA does that, OpenAI Small does that. So these are different kind of framework tools that allows you to build multi-agentic workflows on top of any infrastructure that you have. So they again gonna have the same concept as the agent. So they are gonna have this plugins or also called as a tools, which is a function call that you can make to your existing architecture that you have within your enterprise. It can depend upon your enterprise, whether it could be a monolithic or microservice architecture that you have that you are following within your enterprise, or it could be a call to a third-party service on the whole as well. So while making these interactions, so you need to store them in a database. So on the top, you will be having a database. So this could be a transactional relational database or non-relational database. And also, if you want to approach the RAG in an effective way, you need to have this vector store. So this is what a multi-agentic workflow looks like. But we need to focus on specific areas. As a developer, I'm from a developer background. So whenever we want to develop an enterprise grade application, we need to focus on few areas, like the scalability aspect and the performance aspect. So you need to maintain this highly scalable environment across your layers. It could be at the application layer, or it could be at your infrastructure, or it could be at your LLMs or the database. So in all those layers, you need to ensure that you have a highly scalable environment and also a highly performant environment. Then it should be a cost effective approach. So whatever we are going to see today in our session is going to satisfy all these key focus areas. And also it should be resilient. So how you are handling in case of a failure. Because now since we are interacting with different agents, there is a possibility for you to have a failure at any one of the agentic workflows. So you need to have a mechanism for you to retry those requests and get back the response in a effective way. And also, finally, the security and monitoring aspect is important for any enterprise grade application. So we will see few points covering on those areas as well. So coming to the durable multi-agent. So it is pretty much same as what we have seen in the multi-agentic workflow, with one difference. Instead of having multi-agentic framework implemented on a single infrastructure, now you are deploying those agents into multiple instances. So what this allows you to do is like you can develop an application that is highly scalable and highly performant, which is what we have seen in our key focus area. And after that, the flow will be the same. You will be having a plugin on top of those agents, and those plugins will be interacting with the external worlds, like the monolithic architecture or microservice layer. And then finally, you will be interacting with the database. So this flow remains the same, but only difference is now you have these agents hosted on different instances, and you will be able to scale up to any extent for a single agentic workflow. And this application that I'm going to cover today is going to give you with all these implementations. The link for this will be shared at the end, so you can go through this source code and get to know about all these kind of an implementation. So we have custom multi-agent implementation. We have an implementation for single agent. We also have an implementation for one of the multi-agentic framework that I've used, which is an autogen agent. And finally, we have a support for real-time agent. But this real-time agent will only works in your local machine. In the deployed version, it won't work for now. Then we are making use of these models from the OpenAI. For generation, we are using GPT-4o model. For the embedding model, we are using text embedding models. And for the voice-to-voice conversation, we are using real-time agent. And for the database layer, what we have chosen is Azure Cosmos DB, on top of which we are creating a semantic layer to hold the context and to have a better understanding of your enterprise data. And on top of that, we are developing this vector store layer. And finally, we have this integration with the Microsoft Fabric. So this is the entire architecture, high-level architecture of durable multi-agents. The flow works like, so you have a Blazor application, which is essentially what a customer will be facing. We will also see a demo at the end where you will be get to relate these contents. Once they are making a query, they are asking for some travel recommendations. The request will flow into our Azure Durable Functions. Inside this Azure Durable Functions, we have different sub orchestrators to handle different kind of workflows. And these sub orchestrators does have semantic kernel inside it, which acts as our orchestrator function. So this semantic layer helps us to connect with different kind of models and in an effective way, and also enables you to build a maintainable code whenever you are building an agentic application. And all these agents are in the form of activity triggers. If you are new to Azure Durable Functions, we will be seeing what are those concepts. But for now, just remember these agents are going to be developed as individual activity triggers that has the capability of extending to any extent. Whenever there is a spike of requests coming in, it is able to scale up to any extent. So now, since we are using Azure Durable Functions, we need to mimic the request response pattern. So for that, what I am using here is the pub-sub channel. So this allows you to mimic the request response pattern, because whenever you send in some request to Azure Durable Functions, it will respond back with a 201 accept the request. You won't be getting a response back from it. But for you to get the response, actual response in the chat conversation, you need to have a better user experience. So for that, what I've done is like there is a pop-up channel. I will be listening on to a specific channel, and whenever there is a response that has been placed upon the host channel, I will be updating the UX layer on those situations. And we have a change field with which we will be developing a semantic layer on top of all the transactional data that we have inside the Cosmos DB. And we also develop a vector store within the Cosmos DB itself. And there is a different pipeline for data ingestion, which you don't need to worry about for now. And as I said before, all these agents will be interacting with a monolithic layer or third party services. So even in the this open source project, we have examples for communications with the third party services and also with the microservice layers, so that you will be getting a better picture of how this looks like in an enterprise grade application. And finally, we have this database mirroring concept, which is relatively a new concept that has been released as part of the Microsoft Fabric. So we are integrating with the Microsoft Fabric with the help of database mirroring. And we have other integrations like observability with the eager application inside log analytics. And also we do have the APIM, Azure APIM management for handling this request from the UI layer. So this is the high level architecture of the durable multi-agent. So coming on to the main concept, which is the Azure Durable Functions. So first we need to address why we went with the serverless architecture. So the serverless architecture provides you with a lot of benefits. One of the key benefits are you don't need to rely on the infrastructure, like you don't need to worry about the uh, security patches that you need to do on your own, or anything that is related to the infrastructure. You don't need to worry about. Microsoft will be handling those parts. And also regarding the scalability, you don't need to specify any number of instances by manually, so that will happen seamlessly behind the scenes whenever there is a huge spike of requests. Based on those, the instance of your service will be increased, and you will be paying only for the time that you use. So that is one of the three key benefits of the Azure serverless architecture. And this is gonna be a short-lived. This is a perfect fit for a short-lived application and also a stateless application. But the problem is now we need to have a long-lived application, because the interactions that we make with the LLM might be varying whenever we are gonna the latency that we are gonna receive from the LLMs, because that depends on the context, how much context that you are sending in a single request, and the amount of time that you take for you to interact with the database. Everything adds up uh, in your communications with the chat interface. So obviously you can't rely upon the short-lived nature of the serverless one. And now it is going to be statefulness, because now since we are developing multiple agents, and also we are planning to build multi-agentic workflows, you need to maintain the state between different agents, so that in the case of failures, you know where to start back and where to initiate the request again, like a checkpoint, and start from there. So obviously, the serverless option of Azure is the Azure Functions. We can't rely with the Azure Functions because of the nature of short-liveness and then the stateless. So that is one of the main reason why we chose Azure Durable Functions. It provides you with the capability of running complex workflows that is going to run for the longer time. And since it is going to run on a longer time, you need to mimic the request response pattern. So behind the scenes, you need to make sure it is as similar to how you are interacting with a chat conversation. So for that only, we are having this Redis pub channel in our architecture. And now you do have this statefulness, and the resiliency part is already built on top of your Azure Durable Function. So you don't need to worry about implementing your own retry mechanisms on top of your workloads. It is handled out of the box for you within the Azure Durable Function. And it is a perfect fit for the complex use case. Obviously, the applications that are going to involve Azure, the multi-agents is going to be a complex use case. So this is a perfect fit for those use cases. And some of the patterns that we could implement with the help of Azure Durable Functions are function chainings. This will create a sequential flow within your Azure Durable Function environment, where you can define several functions, and you can define a sequential flow, so that from one function you will be getting a response back with which the function 2 acts upon, and then the further functions will be flowing on in a similar flow. And going on with the different patterns, there are fan out and fan in patterns. This allows you to execute those requests in the parallel way instead of having it in the sequential way. Now you could split the request to different functions, and simultaneously you can handle those requests and consolidate those requests into a single function. So the fan out and fan in patterns are available in the Azure Durable Functions. And also one of the main pattern that we have is the human interaction. Human in the loop will be there. So whenever a human is approving or rejecting, there is a different flow that will be triggered based on that. Until unless like you won't be paying for anything. So even when you are waiting for those. So these are different patterns that you could implement with the help of Azure Durable Functions. So these are some of the plain patterns that you could build with it. So coming on to the LLM world, coming on to the agentic world, you can relate it with the durable multi-agentic workflows as well. So now you could club between different agents, and inside these agents, you could have this semantic kernel as your framework, or you can have your LangChain as your framework, and you could have different models within it. It could be OpenAI, or it could be Metas, or it could be a small language model as well. So now you have the capability to build sequential workflows with multiple agents, and also it could be a long running multiple agent workflows. And you can also build in fan out and fan in requests, which we are already building within this application. For one such cases where I can say is whenever you are asking for a query, rather than relying on a specific keyword and retrieving the information from the database, now you need to also look into the vector database to retrieve the information based on the semanticness of the query that you ask. So what we have as a fan out and fan in pattern is like there will be two requests that will be happening, one to the vector database and other one to your normal database. And the consolidated result will provide you with a better result. So that is what we have used within this Contoso travel agency application as well. And finally, you can also make use of this human in the loop pattern because in some cases, if you are having critical workloads, it is always better to involve human in the loop. So based on the approval or rejection of the human, you can further create a workflow based on that. So this will be provided as an out-of-box patterns within the Azure Durable Functions, and it is entirely a resilient nature. So you will be able to get back to the place where you were facing a failure. So coming on to the memory store, for any agent, for any LLM, if it wants to resemble agent, it needs to have this memory store for different purposes. Like you need to store your chat histories, you need to provide those as a contact to further requests that you make to the LLM. And also you need to have this vector store capability so that you retrieve relevant information rather than information that is retrieved just based on the keywords. So that no longer works in the agentic workflow. So that is where we have this Azure Cosmos DB. So Azure Cosmos DB is one of the most scalable database that I have ever worked with, and it is highly performant and cost effective in nature. We will see different flavors to it, and it is also highly flexible. So let's see like what are the key roles for you to build a robust AI agent memory system before moving on to the Cosmos DB. So one of the key aspects that you need to maintain within your memory system is the speed. You need to have a low latency within your application so that even in the multiple agent interactions, you need to make the decisions on the fly. If your interactions within the database is going to take a long time to get a response back, then it won't give a better user experience to your customers. So you need to have a better memory store for that. So speed is the main aspect that you need to look into. And as for any layer, scalability is one of the main aspect that you need to always rely on. And then simplicity. So even if you are having your existing developers, like it is easier for you to make use of this Azure Cosmos DB because now you are relying on the same SDK, but then you are getting additional benefits out of it. And it is going to be highly available. So you need to ensure that you have this deployment over multiple regions and it is highly available. so that whenever there is a failure in one region, you are able to cater their needs from the other region. And finally, it should be there should be a capability for exposing some real-time events that is happening within the database. Like whenever you update the data or whenever you insert a data or delete a data, so you need to make sure those informations are captured. So you need to have a real-time change notification on top of your database. So these are some of the key aspects that you need to ensure whenever you are building a memory system for your agentic application. And as I said before, there are few flavors to Cosmos DB. One is the NoSQL and the other one is the MongoDB. No, within the NoSQL, you have this capability of running the workloads in a serverless mode. As in the case of Azure Durable Functions, you will be paying only for the request units that you incur, and you also have the capability of provisioning the throughput. You can define certain throughput beyond which your request will be throttled. And there is another version through the throughput mechanism, like you can auto scale. So those different kind of flavors are available within the Cosmos DB, which are the perfect best fit for these agentic applications. And as I said before, they do provide this low latency, and the SLA that they provide is 99.999%, which is what an enterprise grade application should be having. And additionally, now instead of just storing your operational data, now you can store the vector data along with the same collection or within your database. You don't need to rely on a different database just to store the vector embeddings over there and define a data pipeline for those things. You can rely on the same database where you have the opportunity to store your transactional data along with your vector embedding. And there are different indexing mechanisms that is being provided within the NoSQL feature. One of the reason algorithms that they provided us with is the disk and coming on to the MongoDB, so when you want to use MongoDB with NoSQL is simple. So if you have an existing use case that you have within your enterprise that is based on MongoDB, or if you have already have the expertise within your organization around the MongoDB, then you can rely upon the MongoDB for Vico. But for all the customers who are having the experience with the SQL API, you can rely on the NoSQL. And also there are few features that will be available in the new SQL, but not in the MongoDB. So it is better to go with the NoSQL unless until like you don't have the dependency within the MongoDB database. But they also provide the same capability as in NoSQL, like they allow you to store the operational data along with the vector embeddings, and also they provide you with the high reliability. But there is no serverless mode within the MongoDB. It is only available in the NoSQL mode. So this is the serverless nature of the Cosmos DB and some key points that you need to take care while designing this application. So you only pay for what you use, and it is low cost, as you could see here. And it also has a great support for multi-tenancy application and also unpredictable traffic. So those are the exact cases that you will be facing when you are building an agentic application. And there are different use cases that you could build within the Azure Cosmos DB. One such use case is, I can say an example with the ChatGPT. ChatGPT is powered by the Cosmos DB behind the scenes for storing those conversations and retrieving those effective conversations, number of conversations to the contact. So that is entirely maintained by the Azure Cosmos DB. So you can do along with that, there is a capability for you to work with the RAG, because now you have this vector search capability within the same database. And also additionally, you have the capability of semantic caching. What it means is, say suppose a customer is asking a same query with a different keywords, but a same context, then you can respond back with the cache, not directly interacting with the LLM. So those kind of features are available out of box within the Azure Cosmos DB, and it is a perfect fit for agent to agent interaction, so that you can maintain low latency, and the experience that the customer will be getting is the request response reply pattern. Moving on to the next component that we have within this durable multi-agent is the semantic kernel. Semantic kernel, you can go vice versa with this one. Semantic kernel has released the SDK capability for .NET, and the .NET developers are loving semantic kernel for different reasons. One such reason is like it is it is enterprise ready, and it is specifically built for those specific use cases. And we will see why it is different from other frameworks that we have currently. And as I said before, these are some of the key features of semantic kernel. You get this enterprise grade capability out of box, and this is the only framework that has released the version 1 SDK for different languages like .NET, Java, and Python. There is no other languages, there is no other framework that does this, and it bridges the gap between the AI researchers and the app developers. So what is happening is like you will be having an AI researcher team within your organization, and they could be using a different language called say Python, and they can use the same terminologies that are defined within the semantic kernel. And when you want to ship those products to the enterprise, you can give it to an app developer team, which who will be using a different SDK or same SDKs to build an enterprise grade application by based on the same terminology. So this bridges the gap between the AI researchers and the enterprise app developers and reduce the communication between them. And it also creates different abstractions. That is one of the main benefits why we need to rely on these orchestration frameworks. So they have different abstractions for different LLM providers. It could be SLMs as well. So you have different abstractions for that, and you just need to rely on the terminologies that is being defined with the semantic kernel, and you don't need to worry about each of the terminologies that is defined by those LLMs. And you have different integration capabilities, as I said before. You have this multiple SDK capabilities with .NET, Python, and Java. And finally, you have the concept of in-events within this semantic kernel. So that allows you to expose those events into any APMs that you have. It could be Azure Application Insights, or it could be Splunk for any APMs that for sort of a say. You will be having those events generated from this semantic kernel. So the reason for that to happen is this framework. The kernel is the core of the semantic kernel that allows you to have all these kinds of an abstraction. So you can relate it with an dependency injection container. If you are from the developer background, you can relate it with the dependency injection container. So where the flow will happen like inside your application, you will be receiving a request from the user. And you need to select an AI service based on that. So the kernel allows you to uh, do this particular use case. It allows you to select between different models, and it allows you to render the prompt as well. Like templatization is one of the key parts that you need to do along with this. So the kernel allows you to do this templatization, invoking the AI service and producing the response back to the application. And while doing all these activities behind the scenes, it also captured some of the key metrics that you need to expose them in the application performance metrics tool. For you to understand where there is a lag, where there is a performance secret, and those kind of information can be captured with the help of these events. And coming on to the main difference that you get out of the LangChain is, I have worked with LangChain and semantic kernel and also with the prompt flow. Keeping aside the prompt flow, let's focus on the semantic kernel and the LangChain in the first place. LangChain as a framework allows you to have all the benefits that you are getting out of the semantic kernel, but it in a but this will be in a complex way. So you won't be having a maintainable code when you are building your application with the LangChain. And whenever you want to make some changes within your application, you need to make sure you are making those changes in all the files where you reference, rather having those dependencies in a central core, as in the case of semantic kernel. So I see that as a key difference between the semantic kernel and the LangChain, which is the code maintainability. and also the clean code that you could return. Because for an enterprise grade application, you need to have these key aspects. So that will be provided by the semantic kernel, and other features are already available in the LangChain and as well the semantic kernel. Say specifically, if you want to have a JavaScript support and you want to develop an agentic workflow, you can rely on the LangChain framework as well. But make sure you are remembering this point that you won't be having maintainable code within your architecture. And coming on to the prompt flow, you can think it of like an Azure Logic app. So if you are from the Azure background, this allows you to visualize what is happening in your entire workflow in a short kind of a form. But if you want to handle a complex use case within this prompt flow, you need to have some kind of an orchestration. So that could be your semantic kernel or that could be your LangChain framework as well. So prompt flow on the whole as a standalone application can't handle complex use case. If you want to go with the complex use case, you need to again define your workflow based out of these orchestration framework that we have right now. So these are essential differences that you need to understand before choosing a right framework for your use case. So now coming on to our last and main part, which is the observability. So more than ever now, you need to have this observability aspect within your agentic applications, because now we also gonna implement multi-agents, and within those agents we will be having hundreds of function calls within those multi-agents. So you need to have a way to visualize those end-to-end flow. For that, observability plays a key role for you to visualize those phrases within your application. And also, in order to derive meaningful insight out of those information, you need to have an integration with a data platform. For that, we are having this Microsoft Data integration. So some of the common questions that we hear whenever we ship our product to the production stage is like, how is my code working? Is there any performance impact? Or the recent feature that we release is being used by the customer? Like, what is the percentage of user that is currently using those features? Or what are the different KPIs that we need to address? And also, in some cases, you need to depend on the third party performance as well. So these are different common questions that you will be hearing whenever you move on to the production phase. And that is when the observability part comes into the play. So this allows you to monitor each state of your application for all the components that you have within your application. If in case you want to monitor those states of all those components, you need to have the observability. Mostly all of us would have done in some way, they would have done the observability part, like they would have implemented the logs and metrics, like you need to integrate with the application in such like if you are from the Azure background. And also some would have also worked with built-in metrics, or you would have created your own custom metrics, and then you would have created a dashboard out of it in the Azure application inside. But not many of us would have implemented distributed tracing that allows you to visualize end-to-end flow, because now since it is going to be involving the microservice architecture as well, so you need to know in which place you are facing a lag or a performance degrade. So for that, you need to have this distributed tracing, because now the complexity of applications are growing day by day. Rather having monolithic architecture, we are now having the microservice architecture, which is a decoupled one. And in addition to that, now we are also having durable multi-agents, which again is going to be decoupled multiple agentic workflows that we are building. So the complexity is increasing. So unless until you have a better way to monitor those end-to-end flow, you are going to be in a lot of trouble. So let's see like why this matters more now. As I said before, the services are now decoupled, and the agent interactions that you make now is gonna be in an isolated way. So each of those are in a different infrastructures, and within a single agent, now you will be having different function calls, where you will be reaching out to different external tools, third-party services, or microservice architectures. And within those microservice architectures, you will be having different database. It is not like all the microservices could be only built on top of the Azure Cosmos DB. Some of the microservices would have been built on top of SQL servers or PostgreSQL. So there are different kind of database that they could be relying upon. So now you need to understand in which part of the application you are facing the issues. So in those areas, you will be having a great support with the help of this distributed staging. And finally, you need to get the meaningful insights out of these traces. So for that, what we are going to see now is the Microsoft Fabric integration. So this is relatively a new platform that has been released from the Microsoft. So it is an unified data platform, SaaS data platform, where it is a suite of all the different data tools, data and analytical tools into a single workspace. You can compare this with your Microsoft Office, where you have different tools like Excel, PowerPoint, and different other tools inside the Microsoft Office space. So this is similar to that, but for the data purpose, for the analytical purpose, you have the capability of integrating with data warehouse, data lakehouse. You can have the real-time intelligence, and also you can have the integrations with Power BI to visualize them in a nice form. So this entire workflow has been based on the single data solution that they call it as one lake. So all these data are being pumped onto a Parquet data format. So from which that these different tools like data warehouse or data lakes will expose a SQL endpoint and then make use of them from the one lake. So that is how they have achieved this unified data platform. But the plan that they are having in the future is to have transactional database as well inside the Microsoft Fabric. What I mean by that is now you have these databases deployed over the Azure instances, and in the future they are gonna bring this native databases inside the Fabric. So you don't need to create your database on such in the Azure. You can directly come to the Fabric and have those capabilities inside here itself. I believe Azure SQL database is already been added as a native support inside the Fabric. In future, there will be upcoming databases also add to this Fabric workflow. So they are bringing this unified data culture format. So transactional database along with your analytical tools like the Power BI, and they call it as translytical too. So this is what the future will be bringing upon for in case of the Microsoft Fabric. So that's all. So these are the different concepts that I want to share with you. And let's see a quick demo on how this works in the real time. If you want to try it on yourself, you can make a note of this short URL. You will be landed onto the Contoso travel agency application. So let me open the other screen. So this is the landing page of your travel agency application. And here you will be having different suggestions that you can make use of, or you can type your own query. I'm just gonna go with the previous suggestions that I have here. And as I said before, as a suite, you will be getting different implementations. One is custom multi-agent. This is the workflow that has been defined with the help of Azure Durable Functions. And there is a capability for you to run the single agent, autogen agent, and real-time agent. So for now, I'm going with the custom multi-agent workflow. So once I send this request, behind the scenes, what is going to happen is you will be interacting with the Azure Durable Functions. And inside the Azure Durable Functions, we will kick in the orchestration functions. And that will allow us to have different integrations with different multiple agents that we have, and bring those data and publish onto the Redis channel. So from the Redis channel, we will be getting the notification here. Since this has been deployed as an serverless mode, initially for the first time that you run, you will be facing a lag like this. But let me try to see if the existing pre-runs that I did before. Let me open any one of that. Okay, so this is one such a query that I sent before, right before the demo. So now those instances might have gone to the sleep. So that is where there is a bit of a lag. But essentially, what would happen is you could see in the right pane, you could see a different interactions that is made with a different agent. So first, it interacted with the flight agent to get all the flight details based on the date that is specified here. So it looked for the September 10th, and since it is mentioned 5 days, it knows the return date should be September 15th. So what it does is it looks for the departure flight on September 10th, and it looked for the return flight on September 15th, and it found two flights for that specific travel, and then it goes to the weather agent. Based on the weather, it will finalize which will be the optimal plan for you to book, and autonomously it goes to the booking agent, and it straight away book you with a trip. This could be changed into the human in the loop. As I said before, this is just for the POC application. But if you want to build this as an enterprise application, you don't want to have this entire workflow in an autonomous way. Rather, you could have the combination of flight agent and weather agent in the first flow, and then getting the human approval, and then proceeding on to the booking flow. So these kind of flows you can implement with the help of this application. And finally, you will be receiving a notification in your mail that you could see. And that's all I had for today's session. So maybe if there are any questions, I can answer that. Let me see. Okay.
Divakar, there's only one question from Kalyan. I'm putting that up.
Okay. How do
Yeah.
we add bidding for the data in the Cosmos DB? We can enable the feature in Cosmos DB, but how we can? Uh, okay. So this is specific to how we are generating the embeddings based on the data that we receive. So we are gonna have a specific section around that. But for just now, like if I want to answer to that question, like you need to have a different pipeline for it, where you take in the data that you store in the Cosmos DB. You need to make use of the embedding model that we have. It could be the test embedding model or even the smaller model that is from the OpenAI. You need to convert them to the embeddings, and you need to store them in the Cosmos DB. And this could be even more straightforward with the help of the change feed. So whenever there is an update in your transactional workload, you need to update the embeddings as well, because the data might be changing over the time, and you don't need to rely on the stale data in your embedding format. So this provide you with a seamless initiation. So you can have change feed on top of whatever the collection that you have, and inside that change feed, you can have this as a business logic. You can take in the data and create the embedding for those data and upload them into your vector store, which could be again in the same collection. So this way you could create the embeddings within the data in the Cosmos DB.
We have another question. I'm just bringing that up on the screen.
Would you suggest storing embeddings created out of indexing in Azure Search or Cosmos DB? Okay. So there are two questions here. So let me address the first question. So should we use Azure AI Search or Azure Cosmos DB? So this depends on the use case. So if you have your existing workloads that is depending on the Cosmos DB, and you want to generate all the embeddings out of your operational data, you could rely with the Cosmos DB. But there are the relatively better cases where Azure AI Search will be a better fit. If you have different database, and you need to uh, have as a consolidator, create a pipeline on top of it and have those data combined and creating embedding on top of it, you can rely on Azure AI Search. And there is also an additional capabilities that has been provided in Azure AI Search, like the semantic ranking capabilities. If you want to have more probability, Even with Azure Cosmos DB, you could achieve those probabilities. But if you want to have, along with the hybrid search, like keyword plus the vector search, and along with that, on top of that, if you want to have semantic ranking capabilities as well, you can go with the Azure AI search. And also, if you are relying on multiple data sources, AI search would be a better choice of um, your this part, and instead of Cosmos DB. And the next question is, what is the primary difference between the LangChain and semantic kernel? This is something that I already gone through in the session. So when it comes to building a generative AI application, I'm not talking about the POC application. Within the POC application, you can make use of any frameworks of your choice. But if you are already developing your application within LangChain framework, you could relate with this. The code that you write with the LangChain framework is going to be messy, and over the period of time, it is going to grow in size, and the maintainability of the code is going to be challenging in case of LangChain. That is the only main concern that I see as of now. LangChain is also having a great support, as similar to the semantic kernel, even if it is a relatively new. But this is one of the main aspects that I will be focusing on, because we are at the end of the day, like, we need to develop something at the enterprise grade level. So I would always prefer to go with the semantic kernel. But then, as I said before, there are only three SDK capabilities as of now. One is .NET, Python, and then the Java SDK. But if you want to rely on the Node.js, you can go with the LangChain.
Okay, next
So there is
question.
another
Yeah.
question. Yeah. Are we using any search in this application? So yes, we are using the vector search in that capability along with the Cosmos DB for retrieving the relevant information from the database. You can see that. So I believe my screen is visible now. Let me try.
Your screen is up, Divakar.
Okay. Okay. You can say this query, right? So I have asked, can you list my past screens? So this could be a direct natural language to SQL conversion, and then retrieving the information from those parts, or else it could be a semantic search as well. So both of these operations are happening behind the scenes. Specifically, if you are asking for a data that is related to semantic nature of the data, like, say, suppose, for example, I could say, have I visited any beach destinations in the past? So that is something that your natural language to SQL query won't be able to get the response back. But your semantic agent will be able to get the response back, because it knows Goa is something related with the beach destination. If you have visited Goa in the past, it will able to respond you back with those relative information. You can try out these queries in the application. You will be able to uh, get the response back. Okay, there is a question on evaluation. So as part of this application, I haven't implemented the evaluation, but for specifically for evaluation, I would prefer to go with prompt flow. So there is an extensive capability inside prompt flow, and also in the AI Foundry tool, you have these capabilities of understanding whether your agent is responding based on the groundedness of your data, what is the percentage of it, and how much it is varying, and you can build a separate feedback pipeline based on that. That could be a future plan for this application as well. So in the real time, what you could do is, like, you can capture all the queries that you receive, and whenever there is an degrade of performance by measuring those groundedness of the data, you can store them in your database, and you can have that in your feedback data store. So from there, you can also train your data again, so that in the next time when the user is going to ask similar kind of a questions, it can better respond you with an answer.
Great.
What's
We'll
the
take another question.
suggested
Yeah.
UI framework option for the chatbot if you are integrating with MS Teams? Okay, like React. Okay. For now, what you are seeing as a client app is the web application. Say, suppose you want to interact with the MS Teams application, you could do that as well. You can develop a Teams bot application, but inside internally, it is at the end of the day, it is going to be a REST API communication that you need to make. So the architecture that we've seen before, I believe it was shared before in the start of the session. So there, you could replace this Blazor application with your Teams application, and you can make a request to this Azure Durable Functions. It will be as similar to what we have seen now, and instead of responding back with a webhook, we are having this Redis pub sub channel to replicate this request reply pattern. So you could have a different pattern for your Teams application as well. But definitely you could build an application out of the Teams, any client application sort of a say. But the only part is the backend integration is going to remain the same. So you are going to remain with the durable multi-agent, but then the front end is going to be varying. I think those are the questions, right, Rasmita?
Yes, Divakar. For now, I think we are good. You've answered all the questions. And folks, if you have any further question, please feel free to reach out to Divakar. His social handle is already updated on the meetup page. Thank you, Divakar, for hosting this session, and thank you all for joining us today. Please visit Microsoft Reactor website for more upcoming sessions, and also we would appreciate your feedback on today's session as it will help us to curate future session. Please scan the QR code and do share your feedback. Today's event ID is 24517. Feel free to use the Learn module links. This will give you access to additional resources to take your learning further. Thank you all once again and enjoy the rest of your day.